in Pharmaceuticals in association with Higher Secondary Principals Forum.
Let us talk about third case. Now over here when I talk about third case, you see this problem, find the value of constant k. So basically what we are finding value of constant k, and then here see given that. So what is given over here? The given function is continuous at x equal to 0. So over here we are talking about third condition wherein the function is continuous which is given to me. And what I need to find? I need to find the value of k which is mentioned. So basically it is first condition. Look at the situation, look at the setup of the function. It is the first condition. In first condition what is given to us? Here my left hand limit is equal to my right hand limit, right? So over here I am proceeding further. What is given? Let us proceed further with what is given. So I will say since f of x is continuous at x equal to what? 0. Look at the critical points. Which are the critical points over here? 0. And they are saying it is continuous at x equal to 0. So here I am saying the given function is continuous at x equal to 0. So obviously when it is continuous, what it satisfies? It satisfies that equilibrium. So over here I say limit x tends to 0 plus minus f of x. Now why I am saying plus minus 0 f of x? Because we are talking about the first case where my left hand limit is equal to my right hand limit. So over here is equal to f of x equal to 0. Perfect. So this is what is the theory which I am using in this particular problem. So here limit x tends to 0 plus or minus, what is the function? It is 1 minus cos 2x upon 2x square, which is equal to, what is f of x equal to 0? That's k, which is mentioned here. So I am saying it is equal to k. Now I will solve my left hand side to get my right hand side, that is value of k. Okay, so let's proceed further with the first observation. You can see it is trigonometric functions. So we are finding the limit of trigonometric function. Now over here look at this particular formula. Now this particular formula is familiar to you all. Here you know cos of 2x is equal to 1 minus 2 times sine square of x. This is the actual formula. So what I will be doing, I have here 1 minus cos 2x. So I say here 1 minus cos 2x. So this will go here, this will come here. So I will have 2 times sine square of x. This is called as half angle property. Look at it. Here the angle is 2x. What is the angle over here? Half of the angle what I have here. 2x, so half is x. Perfect. So let's proceed further here. So I say limit x tends to 0 plus minus. So what I have in the numerator according to my basic concept of trigonometry, I will say it is nothing but 2 times sine square of x upon 2x square, which is equal to k. Now here, see, I discussed many times over here the formula limit x tends to 0 sine x upon x, and if this angle is x, the same angle must be present over here. Then only the entire setup I can write it as 1, I said. Perfect? So now here also I will be using the similar concept. You can see I have sine square of x. So the angle here is square. So here I have x square. Look, here also I have x square. This 2 and 2 gets cancelled. So I say limit x tends to 0 sine x upon x the whole square equal to k. Now what is it? Now this is nothing but what? It is nothing but 1. This value is what? 1. So 1 square is what? 1. So I get this. So which imply k equals 1. So what is the value of the constant? The value of the constant is 1. Okay. So here look at the problem here. The value of constant you need to find, whereas it is given the function is continuous. So we will be discussing similar kind of problems with respect to previous two cases what we have discussed. Let us start with another example where you also need to find the value of the constants. This is the second problem wherein we discuss the function which is of my second type, and I am saying this function is continuous at x equal to 1, and what I need to do is I need to find the value of a and b. Now one thing you people remember, even if they say the function is continuous, okay, and they don't say like it is continuous at what point. Look at the points here. The function is having break at what point? At 1. You see there is break at 1. You see all the values of x which are greater than x considered here. All the values which are less than x considered over here. So obviously I need to check continuity, or I need to say the function is continuous at x equal to 1. Even if it is not mentioned over here that the function is continuous at x equal to 1. So what I need to do is I need to find the value of a and b, and what is given to me? The function is continuous. Let's start with the solution. So when I start with the solution, what I will do is whatever is given in the problem, let me write it here. So I say since the function is continuous at x equal to 1, look at this, what is given at x equal to 1. So what is the mathematical implication of it? It tells you limit x tends to 1 f of x is equal to f of x equal to 1, which is equal to limit x tends to 1 f of x. So now let me start here. Let me start with the first part of it. I say limit x tends to 1 minus f of x. What is it? 1 minus. So all the values less than x I will consider here. So I say less than 1 I consider here. So I say limit x tends to 1 minus. So 5ax minus 2b equals. So basically here it's 1. This minus sign signifies it is left hand limit. There is no significance of this negative sign here when you substitute value. You just have to substitute as 1. So when you substitute as 1 over here in place of x, you will get 5a minus 2b. Perfect. So this is my equation 1. Let's proceed further with the second one. So second one is limit x tends to 1 plus f of x. So I am talking about my right hand limit. So here what values I consider? I consider all values which are greater than 1. So I am talking about this definition. So I say limit x tends to 1 plus. So over here it is nothing but 3ax plus b. So when I substitute this 1 in place of x, I will get it as 3a plus b, equation 2. Let's proceed further for the third case. What is your third case? F of x equal to 1. You don't have to do anything. Just look at the problem. What is given? It is clearly mentioned over there. At x equal to 1, you are getting 11, right? So over here, this is your equation, or you can say this is your third condition. Let us go to our mathematical implication. What our mathematical implication tells us? That all these three values are equal. So what I do over here with this observation, I will say 5a minus 2b is equal to 11. And then I say again 3a plus b is equal to 11 again. So here this is my equation 1, this is my equation 2. When you look at it, what you remember? You will be solving this simultaneously using elimination method, and you will be finding value of a and b. So let's proceed further for it. So what we do over here is, here you can see it's 2b. Here there is just b. So what I will do, I want 2 to come over here. So I will multiply it by 2. Here for the second equation, first equation I will keep as it is, and I will write 5a minus 2b equal to 11, and when I multiply these 2 throughout, I will get 6a plus 2b equal to 22. So when I proceed, this and this gets cancelled. I will get over here as 6 plus 5, that is 11a equal to, here I will get it as 33. So here I am saying 11 ones are, 11 threes are. Here, so I say here I am getting it as a equals 3. I finished with this. Let me proceed further. Now whatever a equal to 3 I got, I will substitute in one of this equation. So I will get it as, here it is 3a plus b equal to 11. So I say substitute a is equal to 3 in equation 2. So when I substitute, I will say 3 into 3 plus b equal to 11. So 3 into 3 is 9. So over here plus b equal to 11. So I say b equal to 11 minus 9, that's 2. So what is value of a? 3, and what is value of b? That's 2. Here we are done with it. We got value of a and we also got value of b. Let's go to the third problem of case 3. Let's look at the problem. What is given to me here? It is told to me here the function is continuous at x equal to pi by 2. Let me repeat once again. Suppose if it is given, it is continuous, and if the point is not also given, I must understand that I need to discuss continuity, or I can say the given function is continuous at pi by 2. Why? Because you can see the break is where? At x equal to pi by 2. Perfect. So over here what is given? The function is continuous at x equal to pi by 2. I need to find value of k. Now look at this particular function. Let us analyze this function. Now if you look at this particular function, you can clearly say that this is of what kind? This is of your case 2 form, where you have left hand limit, right hand limit, and x equal to pi by 2. Let's proceed further. Now if you look at it carefully over here, I need to find value of constant k. Now here, if you look at this third definition, do you have value of k or do you have k here in the third function? No. So this function is just given as distractor. Okay, so be observable. Look at it here. Look at this here. The k is present in only your left hand limit. So you just have to take your left hand limit and proceed further. This third definition is your distractor. Okay, so you don't have to bother about this third definition. Just look at these two steps and you proceed further. Okay, so let us proceed further. As we write every time, the given function is continuous, right? So I say, since f of x is continuous at x equal to pi by 2, what happens? The given function is continuous at x equal to pi by 2. So obviously this equilibrium, or I can say this mathematical implication is true. So here I am saying limit x tends to pi by 2 minus. Now here while writing, see that you write your definition correctly. Okay, so limit x tends to pi by 2 plus f of x. So this equilibrium is true. This mathematical implication is true. But what we will be doing? We will be taking these two conditions only, these two cases only, and we will be proceeding further. So we will be taking just these two things and we will be proceeding further. Let's proceed. We say limit x tends to pi by 2 minus. This minus sign have no effect here. Okay, just remember that. So here limit x tends to pi by 2 k times cos x upon pi minus 2x. Now with observation you can say the given function is trigonometric function. You are finding limit of the trigonometric function. So here what I will be using? I will be using substitution method. So look at this. Your x is negative. So when I use my substitution, I say put x equal to the limit value, that is pi by 2 minus h. Okay, see the limit value minus h. Why? Because your x variable is negative. I say as x tends to pi by 2, h tends to 0. So this is what is my substitution. With my substitution, let me proceed. I say limit h tends to 0. So it is k times cos pi by 2 minus h upon, I am substituting here. So pi minus, I get 2 times pi by 2 minus h. Be careful over here what is happening. Look, here in the denominator this 2 will go inside, this 2 will go inside, right? And what is happening over here? This 2 and 2 gets cancelled and what remains is pi, and this pi will get cancelled with this pi, and minus sign goes here, and what is left is minus. Minus will become plus. So here I will have limit h tends to 0. So I will have just 2h. Just understand this 2 will go to each term. So 2 and 2 gets cancelled and this pi minus pi gets cancelled. This 2 comes here, minus 2 minus h will become 2h. Then here we go, we say cos. Now look at it. Now cos of pi by 2 minus h. So here we say cos of pi by 2 minus x is nothing but sin x. Why? Because it's very simple, pi by 2 minus x. So we are coming in first quadrant, and in first quadrant all trigonometric functions are positive. So over here I get it as sin, it is h now. So over here look at this. This part becomes 1. Why this part becomes 1? We discussed this formula several times. So limit x tends to 0, sin x upon x is equal to 1. So this part becomes 1. And what is left now? The left part is k by 2. See, k by 2. What is left? K by 2. So this is my first condition. Now here this is nothing but what? It is nothing but here it is f of x equal to 2. So I say, I compare here, let me say this is the thing what I am getting. So I am saying here it is limit x tends to 0 minus f of x, it is equal to f of pi by 2. So over here what I am getting? I am saying k by 2 is equal to, what value is given to me? That's 3, right? So over here I say k is nothing but 3 into 2, that's 6. So here we go. The value of k is 6. See, look at this. I didn't consider this definition at all. I didn't touch this definition at all. This is just a distractor for you. You just focus in what you supposed to do. So that's why you supposed to read your problem, analyze it, understand it, and then you decide your strategy to get your work in simple way. Let us go to the next topic of continuity. Now what we are doing over here is, from one particular point we are talking about continuity over the interval. So from one point we are proceeding further for the given interval. So here we are discussing continuity on an interval. So over here we have two kinds of intervals over here. One is open interval, second is closed interval. Okay, so let's proceed further one by one. So over here, continuity on an open interval. So over here the function f of x is said to be continuous on an open interval a comma b. Here see, when you say open interval, which brackets we use, which braces we use over here? That is here, this kind of braces. And when we talk about close interval, we use this kind of brackets. Okay, so over here we talk about open interval and we say it is continuous if and only if the function, the given function is continuous at every point on the given interval. This is very, very important. So what we were discussing before, at one point we will be discussing over this curve, over this interval. So all such points which are present, what we discussed in our previous case, the continuity will hold good for all these points which are present on this curve. So over here when we talk about open interval, we take all the values from A to B, but we don't take A and we are not taking value of B. We are excluding x equal to A and x equal to B, and that's why you can see I put circle where I didn't shade this particular inner part. You can see I say here I am taking all the values from this point to this point. Here I am talking about this curve and I am saying the given particular function is continuous at all such points which are present over here, then only I can say the given particular function is continuous. So there is no break at any point, I would say, wherein the extreme points I am not considering. Okay, so let us talk about the second situation. Look at the graphs. Now over here the graphs look similar, but remember here this extremities, these are extremities, x equal to a and x equal to b. Both the values I am considering over here. So you can see these circles I have shaded. You can see I shade here this circle. So basically I am considering all such points on this curve, including this extreme point as well as this extreme point. So basically when I talk about continuity on a closed interval, I say the function is said to be continuous on a closed interval. You can see this bracket, try to differentiate here and here. See, closed interval a comma b, if and only if the first condition, whatever happening here in open interval, same need to hold true. You can see here. Here the f of x is continuous on an open interval. Basically what they are talking, the given particular function is continuous at all these points which are present on this curve. You don't have to miss any point and we don't have to say the function is not continuous or discontinuous over this curve. Okay, so whatever criteria are supposed to satisfy here, that is the first condition for the closed interval. Let us proceed further. Second criteria, second condition, what they are saying, limit x tends to a plus f of x is equal to f of a. You can see here this is a plus. What does it mean? It is, here see, you say it is left right hand limit. So you can see f of x equal to a is supposed to be the right hand limit of the curve. So this is what is happening over here. Let us talk about the third condition. Now here see limit x tends to b minus f of x. So b minus, what does it imply? It implies we talk about the left hand curve. So the left hand curve supposed to be equal to your b value. Okay, so remember this is your definition for the open interval and this definition what you have for the closed interval. Fine. So let us talk about two more kind of continuous functions. Okay, this is third kind of continuous function. Here we say the function is continuous over its domain. So we just focused on domain. Domain, when you talk about domain, you remember when you talk about relation, we set A to B. So the parent set, what you say, this set A is called as the domain, or you can say all the first elements present, the first component of the ordered pair. When you list it in set format, what you get is domain. So basically we focus on only its domain. So you can say here the function f of x is said to be continuous if it is continuous at each point of its domain. So here we just focus on domain. So here suppose your domain is minus pi by 2 to pi by 2. So in between all values what you have, for those values the given particular function supposed to be continuous. You are not supposed to bother about what is happening outside. That is not your problem. You just have to concentrate on this particular domain. Understood now what is called as continuous function over its domain. So over here there are different examples what you have. Logarithmic function, you know what is logarithmic functions, you people must have studied what is logarithmic functions. Then we have rational functions, then we have tan, cot, sec, cosec, and not sine and cos. Why? You people must have studied in inverse trigonometric functions the graphs. So when you look at the graphs, you will understand. Here see, here tan, cot, sec and cosec. What matters? The interval matters. What matters over here? The domain matters, right? So over here we talk about only domain, which is here the numbers, or you can say values which are outside its domain does not matter over here. Let's proceed further. Everywhere continuous function. Now what does it mean? Now when you talk about everywhere continuous function, you say the function f of x is continuous everywhere. See here, this is very important. Everywhere continuous in the sense it is continuous on entire real number line. So that is minus infinity to infinity. You don't just focus on only one interval, but you say it is continuous over the entire real number line, that is negative infinity to infinity. Now over here there are many examples of those kind of functions. Constant functions, you know graphs of constant function. You people must have studied this in your 11th standard in the first chapter, that is relations and functions. So over here the constant function, then the identity function, then the polynomial function, we have a modulus function. We discussed modulus function in this particular chapter also. Then we have sine and cos function. Remember, from all these trigonometric functions only sine function and cos function is continuous everywhere, and remaining all four functions are continuous only over its domain. This is very important for you to understand. And the last what comes, that is exponential function. So when you say exponential function, remember your a is supposed to be always greater than 0. It cannot be equal to or cannot be less than 0. Okay. So let's proceed further with the problems of this particular section. Fine. So here we proceed with the problems where we have continuity on an interval. Now we discussed four kind of intervals over here, or you can say four kind of continuities over here. Now from those four kind of continuities, here we talk about the closed interval, the continuous function over closed interval. Now over here let us see now whatever function which is given to me with these three definitions, here is it valid? Now over here let us analyze this particular function. Now nowhere it is mentioned that I need to say the particular function is continuous at what point. So here when you study this particular function, you will understand, you will able to analyze, you need to check which 2 points. Okay. So look at this. Now here see we are talking about closed interval 0 to 8. So you can see over here. So here 0 is included and 8 is included. So we are talking about this here. So let me put it in a line over here. So I am talking about 0 to 8. So over here there are, you can see here you have three definitions, and you can see there are 2 break points over here. Now which are these 2 break points over here? You can see this 2 and you can see this 4. So 2 critical points we have here, that is 2 and this is 4. See why I am saying these are 2 critical points? You can see there is break here as well as there is break here also. So now here basically I am saying the given particular function is continuous over this closed interval 0 to 8. That means I am saying the given particular function is continuous at x equal to 2 as well as at x equal to 4. This is very, very important for you to understand. When closed interval is given, if you want to discuss continuity or if you want to say the given particular function is continuous and when there is no particular point is given, look at the break point of the interval and try to analyze at what point you have to discuss continuity. So at this moment, for instance, what we say, the given particular function is continuous at x equal to 2 and at x equal to 4. Fine. Now over here, see, what we will do is, we will consider this as first case, we will consider this as second case. So let us proceed further. I say, since f of x is continuous on closed interval 0 to 8, f of x, which imply f of x is continuous at x equal to 2 and at x equal to 4. Okay, so what we do here, we will consider the first case at x equal to 2. So let us see what is happening at x equal to 2. So here what we were discussing before, continuity of a function at x equal to a, we supposed to discuss it twice. Why? Because you have two breakpoints over here. So for instance, I am taking first point, so I will be proceeding with a similar way how I used to proceed before. So over here, if you look at it here, my left hand limit is this definition, my right hand limit over here is this definition, which also includes 2. This is very important for you to understand. My left hand limit definition is the first definition. My right hand limit definition is the second definition. Why? Because you can see here for all values less than 2, see, for all values less than 2, what you have over here is x square plus ax plus b, and for all values greater than 2, what you people have, that is 3x plus 2, including x equal to 2. So when I proceed further, I say the given function is continuous. So I say here limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x. Okay, so over here I am saying, which imply limit x tends to 2 minus what I have, x square plus ax plus b, which equal to limit x tends to 2 plus 3x plus 2, which imply, here see, which implies, just substitute x equal to 2. What you people have there? You have here, see, 2 square. So 4 plus 2a plus b. So I get over here, that is 4 plus 2a plus b equals to 3 2s are 6, 6 plus 2 is 8. So I am getting here, which imply, I say 2a plus b equal to 4 comes this side. So you get 4. So over here, this is my equation 1. Let me proceed further for the second. So I say at x equal to 4. So when I say at x equal to 4, here Now look at this, at x equal to 4, what is happening? All the values less than and equal to 4, what definition I am considering? 3x plus 2. So here see 3x plus 2, and all the values which are greater than 4, what definition I am considering? I am considering it as 2ax plus 5b. So let's proceed further with the same note. So over here I am saying limit x tends to 4 minus f of x is equal to limit x tends to 4 plus f of x, which imply, so 4 minus, so my second definition, limit x tends to 4 minus, that's 3x plus 2, which is equal to limit x tends to 4 plus, which in here see, here you have the second one, sorry, the third one, so 2ax plus 5b. So let's proceed further. It's very simple limit. So just substitute x equal to 4 here. So you get 4, when you substitute x equal to 4, 4 3s are 12, 12 plus 4 3s are 12, 12 plus 2, that's 14, which is equal to, when you substitute here x as 4, 4 2s are 8, so you get 8a plus 5b. This is your equation 2. So what I do over here, once I get my equation 1 and equation 2, I say here 2a plus b equal to 4, and the second one, that is 8a plus 5b is equal to 14. Equation 1, equation 2. What I will be doing with it? These are my two equations which I will solve simultaneously using elimination method. So when I proceed further, you can see effectively I can multiply 5 over here and I will get it as 5 2s are 10, so 10a plus I'll get 5b equal to 5 4s are 20. So I get over here, that's here I'll write 8a as it is plus 5b, which is equal to 14. I will change sign throughout and this gets cancelled. So I will get 2a, which is equal to 6. So 2 3s are 6. So over here I get a equals 3. Done. Once I get a equals 3, what I do? I substitute a equals 3 in equation 2. This is my equation. Let me take the simple one. So equation 1. So I say 2a plus b equal to 4. A equals 3. So 2 into 3 plus b equals 4, which imply 2 3s are 6. So here I say 6 comes on this side. So I say b equals minus 2. So I got a is equal to 3 and b is equal to minus 2. This is the second problem where we are considering trigonometric functions, and you can see here the interval what I consider, that is again from my trigonometric functions concept. So over here what I am saying, the given function is continuous on close interval minus pi to pi, where f of x equal to, this is what is given. If you look at this particular setup, what you can say, it is of a second kind of, or you can say second case. Now over here, if you talk about the points, is it given over here it is continuous at what and what point? No. So we will analyze this function and we will find out which points I will consider as my critical points, and I will discuss continuity over here. So over here I say this is minus pi, here I say this is pi. So look at the break. So you can see the break is here. So you can see this is minus pi by 2 and this is pi by 2. So I consider this as minus pi by 2. I consider this as pi by 2. So these are the two critical points where I supposed to be careful. So over here at this moment what is given to me, the function is continuous over here over this interval. So obviously it is continuous everywhere on this particular closed interval minus pi to pi. So at this moment I say the given particular function is continuous at x equal to minus pi by 2 and at x equal to pi by 2. So basically we will be focusing on these 2 points. So let's proceed further, like how I was writing before, I will be writing it again. Here like your language writing part is also important, how you start with the flow, how you logically put statement, that is also important. So over here when I proceed I say since f of x is continuous on minus pi to pi. So this is what is given to me. F of x is continuous at x equal to minus pi by 2 and x equal to pi by 2. Okay, so this is very important. So what I say, since it is continuous over this domain, it is also continuous at these 2 points. So what I do, let me consider the first point here. So I say at x equal to minus pi by 2. Okay, so over here what I am saying is, here say limit x tends to minus pi by 2, f of x is equal to limit x tends to, this is minus this of minus. So minus pi by 2 plus f of x. So let us see now which definition comes under left hand limit and which definition comes under right hand limit. Now over here when you talk about all the values which are less than pi by 2 and equal to pi by 2, which definition it considers? It considers minus 2 sine x. Now let us talk about the right hand limit side. So all the values greater than minus pi by 2, see all the x value greater than minus pi by 2 comes where? In the second definition. So it is nothing but alpha sine x plus beta. Fine. So let's proceed here with it. So here I say which imply, so limit x tends to minus pi by 2 f of x. Now which f of x I will consider? This minus 2 sine x, which is equal to limit x tends to minus pi by 2. This is minus, this is plus. So over here I take alpha sine x plus beta. Now even though it is trigonometric functions, there is no denominator, just expression is given, substitute minus pi by 2. Remember it is minus pi by 2. Now this minus sign is significantly important over here. Okay, so when I substitute I will get it as, you can see here, so x equal to minus pi by 2. You can see, you remember, if you remember here, sine of minus x, you studied it as sine of x. Why? Because sine is odd function. So what happens if the angle is negative? That negative sign comes out and you get it as minus sine x. So if you have minus pi by 2, what will happen? It is minus of sine pi by 2. Perfect. So here what I am getting here is this. So it is minus of 2 times. So I say minus sine pi by 2. Okay. Equal to what I am getting here? It is alpha. Again the same situation it is. So I am saying it is minus sine pi by 2 plus alpha. Sorry, plus beta. Now look at it. Now limit operator disappears. Why? Because that limit value I substitute over here. Now let us proceed. So over here what you are getting it? Minus sine pi by 2. So what is minus sine pi by 2? It's 1. So over here what you get? Minus 2 into minus 1 equals alpha times minus sine pi by 2. So what is sine pi by 2? That's 1. So you get it as minus 1 plus beta. So minus minus will become plus. So you will have 2 equals minus alpha plus beta. So this is equation 1. So we proceed further with the second one. At x equal to pi by 2. Okay, the same thing will proceed. So over here I am taking here limit x tends to pi by 2 minus f of x, which is equal to limit x tends to pi by 2 plus f of x. So let us talk about the definitions. Now at pi by 2, when you talk about left hand limit, what you have is the second definition, and when you talk about the right hand limit, we have cos x, right? So we proceed further with the same note, and here we get limit x tends to pi by 2 minus, my left hand limit is alpha sine x plus, you get it as beta, equals limit x tends to minus pi by 2 plus. At x equal to pi by 2, when we discuss continuity here, we say our left hand limit is equal to our right hand limit. So when we go to the function, when we choose our definitions, what happens is limit x tends to pi by 2 minus. So that is my left hand limit. You can see over here pi by 2 less than pi by 2, which here at what definition these values are there? The second definition. So what happens? I take second definition here, and now limit x tends to pi by 2 plus. So this is my right hand limit. So I take the definition which includes all x values greater than pi by 2. So what is it? Cos x. So once I substitute, what I will do is I will substitute limit value in place of x, and I will proceed further. So here this minus sign has no significance when I substitute here in place of x, but here if you see this minus sign, this is equally important. Why? Because of this minus sign, this everything happens. Now this minus sign just tells you it is your left hand limit. So what I do, I substitute pi by 2 in place of x. So over here I get sine of pi by 2. What is sine of pi by 2? That's 1. So I get it as alpha 1 plus beta, which is equal to what is cos of pi by 2. You get cos of pi by 2, that's 0. So over here I am saying cos of pi by 2 is 0. So I am here with the another equation, that is alpha plus beta equals 0, which further can be concluded as alpha equals minus beta. So you can see I got these two equations. I can solve these two equations simultaneously using elimination method, or what I can do is I write this alpha is equal to minus beta, and this I substitute over here as here alpha. So here what I do is I substitute this here, and what I am getting it here, that is I say substitute alpha equals minus beta in equation 1. So when I substitute, what I get is alpha equals minus beta. So minus will become plus. So what I am getting over here is, look, it is 2 times 2 equals, it is minus beta plus beta. So which is nothing but 2 equals 2 beta. 2 cancels, and I say beta equals 1. So I am getting beta equals 1. So when I say beta equals 1, according to my previous setup, what I can say is alpha equals minus 1. Okay, so here what we conclude, that beta equals 1. This is what I need to find, and alpha equals minus 1. This is also what is required. Here see, instead of solving it simultaneously, what I did is I use substitution method to get the values of alpha and beta. Okay, so let's go for the next problem. So here we talk about our third problem. Here we come up with another condition which includes mod. Okay, so you can see the function is equal to mod of x minus 4 upon x minus 4, where x is not equal to 4, 0. Here you get when x equal to 4. If you remember, we studied or we previously discussed mod function. When you get mod of x, you say it is minus x when x is less than 0. Now at this moment, what we have over here is 4, and now here it's plus x when you have all x values greater than 4. So what we do, we modify our modulus function and we get it in this form. So what we do with this note, let me proceed further. I will rewrite my function. Always I told you all, here the moment you get mod sign, see that you rewrite your function and you write it in simplified form. So when I rewrite using my this concept, what I do, minus x minus 4, see minus x. So minus x minus 4 upon denominator as it is when x less than 4. So all x values less than 4. So this gets cancelled, you get minus 1. So here you talk about positive x. So x minus 4 upon x minus 4. So cancels, you get 1. So x greater than 4. And 0, which is here, I am writing as it is. So when you look at this simplified form, you don't have to do anything. With observation only, you can make out your left hand limit is not equal to your right hand limit, and it is also not equal to f of x equal to 4. Okay, so what happens? See, here we are talking about show that the function is continuous everywhere except x equal to 4, right? So here we have to argue such a way that here what I must say, that is here when x greater than 4, see when x is greater than 4, what you get, that is f of x equal to 1. You can see here greater than 4 you get as 1. So here you say the function, you can say since it is constant function, it is constant function 1, right? So constant function. So you can say f of x is continuous at x greater than 4. So for all values here f of x is continuous at this. So here we talk about second condition when x less than 4. What you get there? F of x equal to minus 1. Look at that. So again it is constant function. So since it is constant function, okay, what you say, your f of x is continuous for all x less than 4. I say for all x less than 4. So I managed to take my left hand limit, I managed to say about my right hand limit, and it is constant function. So when we talk about constant function, it is continuous everywhere. Remember this. So we finished with this. We are talking about here at x equal to 4, and it is very obvious from the function what I am getting is limit x tends to 4 minus f of x, which is not equal to limit x tends to 4 plus f of x, which imply here minus 1 is not equal to 1. So you can say hence f of x is not continuous at x equal to 4. So see, we proved it that the function is continuous everywhere over all the values of x which are greater than 4, all values of x which are less than 4, but it is not continuous at x equal to 4. So I say therefore f of x is continuous everywhere except x equal to 4. Okay, so this is all about your continuity. Next time we will proceed with derivatives.
Prudent Scholars, powered by Lupin Pharmaceuticals.